Completing the square with adamonlinetutoring. Here are the beginner questions, some of the easier questions that you're likely to find on this topic. Completing the square is a method used to solve quadratic equations, rewrite quadratic expressions in vertex form, and find the turning point, which is also known as the vertex, the stationary point, or the maximum or minimum point of a parabola. Completing the square is in the form of x plus a squared plus b. So if we're completing the square for x squared minus 4x minus 5, we need to think about a squared bracket, which will give us x squared minus 4x when expanded. And we can do that quite quickly by having a squared bracket with x, keeping the sign the same that's in between the two terms, and then halving the coefficient of the x term to give me 2. Now let's see what happens when we expand x minus 2 squared. X multiplied by x is x squared. X multiplied by negative 2 will be negative 2x. That will be the same for this term. And then negative 2 multiplied by negative 2 will give me positive 4. If we simplify this, we'll get x squared minus 4x plus 4. Notice how we get x squared minus 4x, which is the same as the bit that I wanted here. Hence, you can see that method of dividing the coefficient of x by 2 is a useful shortcut. But not only have we got x squared minus 4x, but we've also got this additional 4 at the end, which I didn't want. I actually wanted negative 5, so I need to think about how I can get back from 4 to the desired constant, which was negative 5. Once x minus 2 squared has been expanded, I can get back from 4 to negative 5 by subtracting 9. I now have the original quadratic of x squared minus 4x minus 5 in the completed the square form. To avoid expanding the squared bracket each and every time before having to look at the difference of how you get back from this number to this number, there is another shortcut that we can use back when we completed this step. Once we have our squared bracket and we divide the coefficient of x by 2, we know that when we expand this, we will always end up with negative 2 squared at the end, which is positive 4. So straight away, we can subtract whatever this number is squared to reset the quadratic back to 0 before then subtracting 5 to get down to the required negative 5. We can then just put one additional step in where we simplify by collecting like terms. Negative 2 squared is negative 4, and taking away 5 will collect to give me negative 9. You can see how this matches up with the previous answer. Once we have completed the square form, we can use this really quickly to find the turning point of the graph of y equals x squared minus 4x minus 5. The turning point may also be referred to as the vertex, a stationary point, or a maximum or minimum depending on the type of quadratic you have, with the most popular phrase tending to be the vertex. For the x part of the coordinate, we can always take the constant inside the bracket of negative 2 and use the same number but switch the sign. So in this case where we have negative 2 inside the bracket, the x value of the turning point would be positive 2, and the y part of the coordinate will always be equal to the constant that you have at the end, with no need to change the sign, so negative 9. The reasons for this will become more clear when you move on to look at graph transformations. On to the second question, worded slightly differently. By completing the square, find the coordinates of the turning point of the curve. They didn't have to tell us to use completing the square here. We need to start recognizing that if you're asked to find the turning point or the vertex, that completing the square is usually the best way and the easiest way of being able to do this. So if y is equal to x squared plus 10x subtract 8, using both of the shortcuts discussed on the previous question, I can use the first two terms here to create my squared bracket. Y is equal to x, and using the same sign in between the two terms, before halving the coefficient of the x term to give me x plus 5 as my squared bracket. It doesn't matter if we have a positive 5 or a negative 5 inside the bracket, we would always subtract the number squared. And the reason for that being, whether you square negative 5 or positive 5, you're always going to end up with positive 25. So you will always want to subtract that amount to reset it back to 0 before subtracting 8. Simplifying, y is equal to x plus 5 squared, and then negative 25 subtract 8 is negative 33. The vertex, or the turning point, will be this number with the inverse sign, so negative 5. for my x part of the coordinate, and then negative 33 for the y part of the coordinate. On to the intermediate questions with an increase in difficulty. We need to write x squared plus 3x minus 7 in the completed the square form. This doesn't appear very different at first, but the difficulty comes when trying to create the squared bracket. Notice that the coefficient of x is not an even number, so when halving it, we'll end up with a fractional amount or a decimal. I'd advise you to keep it as a fractional amount when completing these questions. So x plus 3 over 2 squared, and following the same shortcuts as before, I would need to subtract 3 over 2 squared to reset it back to 0 before subtracting 7. Simplifying by collecting like terms, my completed the square form will be x plus 3 over 2 squared. 3 over 2 squared is the same as 9 over 4, and negative 7, written using a common denominator, would be the same as negative 28 over 4. These common denominators will make it easier to collect like terms, giving me x plus 3 over 2 squared minus 37 over 4 as my completed the square form, and my vertex or turning point for the x part of the coordinate will be negative 3 over 2, and for the y part of the coordinate, negative 37 over 4. For the second question, we need to find the coordinates of the turning point of the curve with y equals 2x squared minus 12x plus 23. We'll only be able to use the same methods as in the previous questions if we have part of the original quadratic in the form of x squared or 1x squared rather than a coefficient greater than 1, such as 2x squared. So when in this position, we'll need to take a factor of the coefficient of x squared out. And there are a couple of different ways of completing this, which involve taking a factor of 2 out of all of the terms, whereas I find the approach easier where we just take the factor of 2 outside of the first 2 terms. So factoring out 2 from these first 2 terms, y is equal to 2 bracket x squared minus 6x bracket and then plus 23. Now I have x squared minus 6x in a very similar form to how I've had my previous questions, such as x squared plus 3x. So I can leave my factor of 2 outside and go ahead and complete the square in the same way as I have previously, where I have x minus half of the x coefficient, giving me a squared bracket of x minus 3. Typically at this point, I would subtract 3 squared to reset this back to 0, but at this point I need to remember that this squared bracket is actually being multiplied by 2. So to reset it back to 0, I'll actually need to multiply the 3 squared by 2 before adding 23. Now I can simplify by collecting like terms. My completed the square form will be y equals 2 bracket x minus 3 squared, and then negative 2 lots of 3 squared is negative 18, and adding 23 will give me positive 5. My turning point is found in exactly the same way as the other previous questions, and the 2 being on the outside of the bracket does not impact either of the x or y parts of the coordinate. Again, you'll grasp more of an understanding for why this is after you've done graph transformations. So the x part of the coordinate would be positive 3, and the y part of the coordinate would be positive 5. On to the advanced question, one of the trickier questions that you're likely to find on this topic. By completing the square, we need to solve the quadratic equation, and we need to give our answers in surd form. The first thing to notice is that this is not written in the form of ax squared plus bx plus c, so it will probably be helpful if we can do some slight rearranging so that it is. So I'll start by switching some of the terms and writing negative 5x squared plus 20x plus 3 is equal to 0. Not only do we have a factor of 5 that we need to take out, but it's also a negative coefficient, which again will make the question easier if we can factor this out. So we'll actually start by taking a factor of negative 5 outside of these first 2 terms. Negative 5 bracket x squared, and dividing 20x by negative 5 is negative 4x plus 3 equals 0. Go ahead and complete the square in the same way as we would normally with the x squared minus 4x part, giving me negative 5 lots of x minus 2 squared, and typically I would subtract 2 squared, but this is actually being multiplied by negative 5 before adding 3, which creates this situation where we're subtracting a negative value, which would be the same as adding. So negative 5 lots of x minus 2 squared plus 5 lots of 2 squared plus 3 equals 0. and simplifying by collecting like terms will give me a final completed the square form of negative 5 lots of x minus 2 squared plus 5 lots of 2 squared is 20, and then adding 3 is positive 23. This completed the square form makes it easier to solve. Since x only appears once, I can use my knowledge of solving equations to work backwards to find x. I can do this by first taking away 23 from both sides of the equation. Negative 5 lots of x minus 2 squared is equal to negative 23. Next, I can divide through by negative 5. X minus 2 squared is equal to 23 over 5. Square root both sides, giving me positive or negative root 23 over 5. The third root 23 over 5 can be rationalised, but this is optional at the GCSE level. And finally, I can find x by adding 2 to both sides, giving me my solutions for x, which would be 2 plus or minus root 23 over 5. Here's a question that I've completed earlier. It appears as though I've made some mistakes. Pause the video and see if you can spot what they are before writing some corrections in the comments below.
Thanks for watching. If you found that video useful, don't forget to hit the like button and leave a comment. If you're struggling with topics or finding maths difficult, subscribe and turn on notifications to receive regular updates about new video tutorials and other useful content. You can visit and follow all of my socials by clicking the links in the description below.